Good morning to all of you. In the previous class, we have learned about the basic definitions of lines and angles, and today we are going to learn about the types of angles. In the previous class, we learned about how the angles are formed, and now we are going to learn about the types of angles, different types of angles. So, see the first one, this is acute angle. First type of angle is acute angle. So what is acute angle here? An angle whose measure is less than 90 degrees is called an acute angle. Whose angle is less than 90 degrees is called an acute angle. If you observe here, this angle is starting from here. Okay, if there is no angle is forming by two rays, that angle is called as a zero angle. That is another definition you will learn later. So this is the zero angle. So when it starts from here and rotating like this, all of you know that if two rays are rotating at a fixed point, they will form an angle like this. And see here, this is 27.83 now, and it is increasing while I am rotating like this, 38, 41, 43, 50, 60, 70, 80, 90, like that. When it reaches to 90, that angle is called as the right angle. Okay, if it is at an initial point, this is called as the zero angle, and this point is at this point at 90 degrees, it is called as the right angle. But if the angle is in between these two, 0 and 90, if the angle is in between this 0 and 90, anywhere in between these two angles, those angles are called acute angles. All these angles are acute angles from 0.01 degree to some 0.001 degrees to here 89.99 up to there. All these angles are called acute angles. Okay, these are all acute angles. What is the definition of acute angle? An angle whose measure is less than 90 degrees and greater than 0 degrees also is called as an acute angle. Okay, in this figure, angle POQ is an acute angle. So that's the definition of an acute angle. Next, obtuse angle. What is the meaning of obtuse angle here? Here, after reaching the angle to 90 degrees, that is called as the right angle. Okay, if it is like this, this is called as the right angle. After right angle, when it rotates like this up to the 180 degrees, means below 180, above the below 180 degrees and above the 90 degrees, all these angles are called obtuse angles. Okay, so what's the definition here? Read here. An angle whose measure is greater than 90 degrees and less than 180 is called an obtuse angle. If it reaches to the 180 degrees, that angle is called as another one, which is called as right angle. Okay, if it is at zero angle, if it is coincided with the initial point, that is called as a zero angle. If it is at the middle like this, at 90 degrees, that is called as the right angle. If it is at 180 degrees, that is called as the straight angle. Okay, so in between 90 and 180, all these angles are called as the obtuse angles. Okay, all these angles from 91.1 angle up to 179.99 angle, all these angles are called as the obtuse angles only. You see here 159, 50, 62, 133, all these angles are called obtuse angles. Okay, that's the definition of the obtuse angle. Okay, so this is obtuse angle. 141.12 degrees is obtuse angle. So these are the acute angle and obtuse angle. Next, third type of angle is right angle. Fourth one is straight angle. Already I told you in the previous screen when I am explaining about the acute angle and obtuse angle. Okay, when the ray reaches to exactly to the 90 degrees of angle like this is called as the right angle. An angle whose measure is exactly equal to 90 degrees is called a right angle. So this is the right angle. So in the figure, angle TOP is a right angle. So this is the right angle. Next right angle is an angle whose arms form opposite rays is called a straight angle. It has a measure of 180 degrees. Therefore, angle COS is a straight angle. Okay. So if the angle in between two rays is 180 degrees, those two angles, that angle is called as the straight angle. That is also called as the straight angle, because these two rays forming a straight line like this. These two rays are opposite rays are forming a straight line. That's why this is called as a straight angle. Okay, this is the fourth type of the angle. Next types of angles are here reflex angle, complete angle, and zero angle. So reflex angle means you know what is the straight angle. After straight angle, if it rotates more than 180 degrees like this, if this is the straight angle, you know that all of you 180 degrees. If it rotates more than 180 degrees and when it reaches to the 360 degrees, in between 180 and 360, all these angles are in between 180 and 360, means the angle which is greater than 180 degrees and less than 360 degrees. All these angles are called as the reflex angles. All these angles are called as the reflex angles. This is a straight angle, and these angles which are 225, 270, 260, 333, all these angles which are less than 360, which is 359.999, all these angles are called reflex angles only. Okay, so what is the definition here? Angle whose measure is greater than 180 but less than 360, greater than 180 but less than 360, all these angles are called reflex angles. Okay, here 326.18, this is also a reflex angle. Okay, next one is the complete angle. When it completes a full rotation like this, okay, and completes up to 360 degrees, this angle is called as the complete angle. Okay, an angle whose measure is 360 degrees is called a complete angle. Okay, generally initially it starts from here. This is a zero angle. These are all acute angles. When it reaches to 90 degrees, that is called as the right angle, and after 90 and below 180, all these angles are called as the obtuse angles, and when it reaches 180 degrees, this is called as the straight angle, and greater than 180 and less than 360, all these angles are called as the reflex angle, and when it completes a one rotation like this and reaches to 360 degrees, then this angle is called as complete angle. This angle is called as complete angle, which is equivalent to 360 degrees. Okay, so now an angle whose measure is 360 degrees is called a complete angle. It means the ray has rotated to meet at its original position. See here, its original position, it is coming like this, and it is showing by an arrow like this. It is rotating like this completely. Okay, always you have to show an arrow to indicate the complete angle. Okay, this is an XOY angle. Some angle XOY is the complete angle. Okay, next one is the zero angle. If an angle of measure is 0 degrees only, means if it is not rotated at all, then the angle between these two rays is only 0 degrees. An angle whose arms coincide with each other without taking any rotation is called zero angle. So this is a zero. For zero angle, you should not indicate any arrow like this. But for 360 degrees, you have to show this angle. That's the main difference in between zero angle and complete angle. indication with the geometrical figure. Okay, geometrically if you want to show, both are looking like this only. You see, if you observe, both are looking like this only, but if you want to indicate the complete angle, you have to show this angle, this rotation arrow you have to show. But for zero angle, you should not show any angle, just you have to coincide these two lines like this. That itself indicates the zero angle. Okay, so these are the 7 types of angles. First one is acute angle, which is greater than 0 and less than 90. Okay, next one is obtuse angle, which is greater than 90 and less than 180 degrees. Next one is what is the next one? Acute, obtuse. Next, right angle, which is exactly equal to 90 degrees is called right angle, which is exactly equal to 180 degrees is called straight angle. And an angle which is greater than 180, here you can see here, greater than 180 here, which is greater than 180 and less than 360. All these angles are called reflex angles. And when an angle completes one rotation and it has an angle of 360 degrees, that is called as the complete angle. And an angle which without taking any rotation, it forms an angle which is called zero angle. This is the 7th angle. Okay, all these 7 types of angles are there. Okay, next one is pairs of angles. For the completion of the types of angles, you are going to learn about the pairs of angles. Here two angles you have to take, and some relation will be there in between those 2 angles, and some names are there for the pairs of angles. So see, the first one is the adjacent angles. The literal meaning of adjacent is nearby or neighboring or side by side. Okay, adjacent means nearby or side by side angles, which are nearer by or neighboring angles like this. So see the definition here, listen carefully. 2 angles are said to be adjacent if they have a common vertex and a common arm, and non-common arms lying on the opposite sides of the common arm. See here, 2 angles are here. 2 angles you can see here. This is 90 degrees, this is also 90 degrees. I am taking same angle. When they are called as adjacent, if they have a common vertex like this. This is the common vertex. Okay, common vertex and a common arm like this. This arm is common for this angle and this angle also. This arm is common for, means it is same for this angle and this angle. Common means same angle. Yes, common arm means same arm for both the angles. Okay, and non-common arms for, this is the non-common arm for these 2 angles. These 2 non-common arms are opposites, are lying on the opposite sides of the common arm. These 2 non-common arms are lying on the opposite sides of the non-common arms. Okay, this is opposite to this one, this is opposite to this one. Okay, then these 2 angles are called adjacent angles. Okay, they should have a common vertex and a common arm, then only those 2 angles are called as the adjacent angles. Here angle XOY and angle YOZ, these 2 angles are called as the adjacent angles. Here what is the common vertex here? O. See the common vertex, and OY is this is the common arm. Okay, and OX and OZ are the non-common arms which are lying on the opposite sides of this common arm OY, which are lying on the opposite side of common arm OY. So that's why angle XOY and angle OYZ are the adjacent angles or nearby angles or side by side angles, and there is no need to equal these 2 angles. Maybe they are like this also. These 2 angles, this is 116.57, this is 63.47. These 2 angles are also called as the adjacent angles, because these two angles have a common vertex and a common arm, and these two non-common arms are lying opposite to each other. That's why these two angles are called adjacent angles. And these two angles also adjacent angles, these two angles also adjacent angles, these two angles also adjacent angles. Okay, because all these angles have a common vertex and a common arm, and non-common arms are lying opposite to the common arm, like this. Okay, so this is the definition for adjacent angles. All these definitions are very important while you are doing the and solving the problems in the exercises. Next type of pairs of angles are complementary angles. These already you know that in the previous classes also. What are called as the complementary angles? Any two angles whose sum is 90 degrees are called complementary angles. Observe here, these two are separately shown here, but adjacent angles are having a common vertex and common arm, but these two are having different vertices and different arms are there here, separately shown. But if the angles, if the sum of these two angles is equal to 90 degrees, then these two angles are called complementary to each other. Complementary to each other. This XYZ is complementary to some this. If I take PQR, this PQR angle. This is XYZ is complementary angle to PQR, and PQR angle is complementary to XYZ. Like that you have to read. In this figure, here I have taken AOB here. If I take this as AOB, this angle AOB plus angle XYZ is equal to, here 65 plus 25 I have taken. Okay, you can take here in the figure 45 plus 45 is there. 45 plus 45 is also 90. So these two are also complementary angle. If I take this as 65, for example, like this 65 somewhere here, and this as 25, by adding these two angles also you will get 65 plus 25 is 90 degrees nearly. So these two angles are also complementary to each other. Exactly, if you take complementary to each other. Okay. So what is the definition for complementary angles? Any two angles whose sum is 90 degrees are called complementary angles to each other. Okay, there is no need to have a common vertex and common arm here, but in adjacent angles they should have a common vertex and common arm. Okay, that's the definition of the complementary angles. Next one, supplementary angles. So what is the definition of supplementary angles? This also you have learned in the previous classes. Two angles whose sum is 180 degrees are called supplementary angles. Observe here, these two angles are separately drawn here. There is no common vertex and common arm here. Okay, two angles whose sum is 180 degrees are called supplementary angles. If we take this is 130, this is 50. 130 plus 50 is how much? 180. Okay, that's why angle TOP and angle EFG, these two angles are supplementary angles, supplementary to each other. Also, like that we can read. Okay, angle TOP and angle EFG are supplementary to each other. If I take here somewhere 90 degrees, okay, and this also I have taken as 90 degrees, and 90 plus 90 you will get 180 degrees. So these two angles are supplementary to each other. Okay, like that we can take. So exactly, if you take 90 degrees like this, okay, 90 plus 90, 180 degrees. Okay, so two angles whose sum is 180 degrees are called supplementary angles. Supplementary angles also they are separately shown here like this. Okay, so next type of pair of angles are vertically opposite angles. Vertically opposite angles are formed by taking two lines and intersecting them to each other. Already I told you, when the angles are formed, the second possibility of forming the angles is, or third possibility of forming the angles is, when two lines intersect to each other like this. Here observe here, these two lines L, M are not intersecting to each other and not forming any angle also. If they are intersecting to each other at a common point like this, they will form angles. Here four angles are forming here, but here there is a property which is vertically opposite angles always equal. Vertically opposite angles means which two angles are opposite to each other are called as the vertically opposite angles here. Here this angle is opposite to this one and this angle is opposite to this one. So these two angles are equal, 124.59. This is also 124.59. This is 55.41. This is also 55.41. Since these two are vertically opposite to each other, these two angles are equal and these two angles are also equal. This is a very important property which will be used in the finding of angles in the solutions of the problems. Okay, when two lines intersect each other, two pairs of angles are formed. In the given figure, when the L line intersects the line M, the angles angle 1, 2, 3, 4 are formed here. Here I have not shown. So four angles are formed here. Here angle 1 and 2 and angle 3 and 4 are vertically opposite angles. Okay. So the vertically opposite angles are always equal. Therefore, if it is 1 and this is 2, these two angles are equal. If it is 3 and this is 4, these two angles are equal. Okay, this is very important and this will be used in the solving the problems. Next, fifth type of pairs of angles and important one is linear pair of angles. Linear pair of angles. This is the combination of adjacent angles and supplementary angles. This is a combination of adjacent angles and supplementary angles. Observe here, these two are adjacent angles. All of you know that because these two angles have a common vertex and a common arm like this. Okay, common arm like this. Then common arm like this. These two angles are called as the adjacent angles, and the sum of these two angles is 180 degrees also. In adjacent angles, there is no need to have the sum as 180 degrees. Okay, in adjacent angles, there is no need to have the sum of the two angles is 180 degrees exactly. But in linear pair, they should be adjacent and the sum of the angles should be 180 degrees. Then only these two angles are called as the linear pair. Linear pair. And there is no need to be the two angles are equal like this. You can take like this also. Here 111.8 and 68.2. These two are also linear pair. These two are also linear pair because these two angles are adjacent to each other and the sum of these two angles is 108 degrees. So these two properties should follow to become the given two angles are linear pair. Okay, so if you take like this is 45 degrees, this angle is 45 degrees, this is 135. So 135 plus 45 is 180 and these two angles are adjacent to each other because it is a common arm and this is a common vertex. This is a common arm and this is a common vertex. Since these two are adjacent to each other and the sum of the angles is 180, these two angles or pair of angles are called linear pair. Linear pair. Why they are calling as linear? Linear means they are forming a line like this, straight line. Line, from line the linear is formed. Okay, the word linear is formed here. Linear angle is forming. Linear angle means 180 degrees angle. Linear angle means 180 degrees angle here. They are forming. That's why when the sum of two adjacent angles is 180 degrees, when the sum of two adjacent angles is 180 degrees, they are called linear pair of angles. That means in adjacent angles, if they are only the adjacent angles, there is no need to be the sum of the angles is 180 degrees. If it is 180 degrees, those pair of angles are called linear pairs. Okay, that is the difference between adjacent angles and linear pair. Okay, so in the given figure, angle AOC plus angle COB is 180 degrees. Therefore, angle AOC and angle COB form a linear pair of angles. Okay, next, these are the four important properties we will learn here. Two acute angles or two obtuse angles can never form a linear pair. Observe here, these two angles are acute angles only, because this is less than 90 degrees 45 degrees, this is also 45 degrees. Observe here, 45 plus 45 is how much? Two acute angles, 90 degrees. Since it is 90 degrees, it cannot form a linear pair. Linear pair means it should form a 180 degrees of the angle. So two acute angles can never form a linear pair. And also, if you take two obtuse angles means what here? If you take this angle, this is 90 plus 45 is 135 degrees. Okay, 135 degrees. This is one of the obtuse angle from up to here. And this is 180 degrees. This is also an obtuse angle only, which is greater than 90 degrees. Okay, otherwise you can take like this. If I take this one, this is 116.57, which is obtuse angle. This is also greater than 90. This is 116 degrees angle. If you omit this one, you can understand this. This is 116 from here to here. This is 114. Means which are greater than 90. Means these two angles are obtuse angles. Observe here, by adding these two angles, you will get an angle which is greater than 180, because 114 plus 116 is how much here? 230 degrees you will get, which is greater than 180. Okay, it is greater than 180, but it should be 180 degrees only. That's why two obtuse angles can never form a linear pair like this. Okay, two acute angles will never form a linear pair, and two obtuse angles also will never form a linear pair. Okay, so this is the first property. Next, supplementary angles form a linear pair if they are adjacent to. Supplementary angles form a linear pair if they are adjacent to. Okay, supplementary angles means these two angles, the sum of the two angles is 180 degrees, and they are adjacent also, they will form a linear pair. This property itself, it is written in this form. Okay, same, both are equal here. Supplementary angle, these two angles are supplementary to each other, and they are adjacent to each other also, then they will form a linear pair. Okay, if they are not adjacent to each other, they will not form a linear pair. Why it is? How can you tell that? See here, these two are complementary, these two are supplementary angles, but these two angles are not adjacent to each other, because these two angles have two different vertices and two different arms here. If they are forming like this, which is having a common vertex and a common arm, then these two angles are called as the linear pair. Okay, generally supplementary angles may not be like this, they will be like this also separately. They have a different vertices and different arms like this. That's why the second property is written that if the supplementary angles have a common vertex and a common arm, means if they are adjacent to each other, then they will form a linear pair like this. Okay, that's the second property. Okay, so next property is here, the sum of all the angles on a straight line is 180 degrees. Sum of all the angles on a straight line. See here, this is a straight line. On the straight line, these three angles I am showing here. If you take the sum of these three angles, you will get 180 degrees. See, 90 plus 45 plus 45 is 180 degrees. If you take some other angle like this also 63 plus 71 plus 40, something is here. If you take like this, 63 plus 49 plus 66. If you add these three angles, this also will give you 180 degrees. This is 120 something, this is 50, 180 you are getting if you add these three things. So therefore, the sum of the angles, all the angles on a straight line is always 180 degrees. Observe here, this is 180 degrees. This is also 180 degrees you will get. The sum of all the angles completing a rotation about a point is 360 degrees. So this is the center point I am taking. About this point, all the angles which are completing a rotation like this, the sum of all these angles will give 360 degrees. About a point, all these angles will form total 360 degrees. See here, up to here, this is 180. This is also 90 plus 45 plus 45 is 180. 180 plus 180, 360 degrees. Okay, 360 degrees. If I take this angle like this somewhere, and if I take this angle like this, if you add these four angles also, you will get exactly 360 degrees. The sum of all the angles completing a rotation about a point, completing a rotation about this point, the sum of all these angles is 360 degrees. This 90 plus 98.27, 100.16 and 71.57. By adding all these points, always you will get 360 degrees. This property is also very important while you are doing the problem. The sum of all the angles completing a rotation about a point is 360 degrees. So up to here, these are the different pair of angles. Okay, so up to now I would like to conclude this session. In the next class I will explain the problems on this chapter in exercise 9a. Okay, good day to all of you.